All right, welcome everybody. I think we're good to go. So, a couple things to get started here. Remember, you can always send me questions if you want. Sometimes, if I get a question, it might be a good one to cover in class next time. So, if you're feeling like you're confused or whatever, feel free to send me a question, and I can take a look at that. Otherwise, I'm available in office hours. The tutoring center has tutors who can help you with all of this algebra stuff. So if you feel like you're confused or getting behind or anything like that, don't just sort of suffer in silence, because then you'll end up probably not passing. Make sure that you're seeking help and getting help to help you be successful in the course. Okay? With that said, couple things to start off with. So main Ventura College webpage. Remember, if you just click up at the top, academic calendar, couple things on this page. So for starters, just a reminder, because the 14th, I think, is the day we're expected to be back on campus. So that's a couple weeks from now. And you will not be getting in the classroom without a wristband, or you might get in and then I'll have to tell you to leave. A wristband and a mask. Without those, you cannot be on campus. So the way the wristband works, I'll bring this up again so that everyone's sort of ready for that first day. So the way it works is you've got your vaccine card, right? You can't get on campus if you're not vaccinated. If you're vaccinated, upload your vaccine card now to the app so that they can put you in the category of people who are vaccinated, and then you can come on campus. Otherwise, it's just going to kick you out of the system. You won't get approved to come on campus. So you upload that. Don't do it the morning of, because I'm sure you and 5,000 other people are going to do it February 14th. Guess what? It's going to take a little time to put all that stuff through, or they're expecting it to. So I would upload that card now to make sure you're good to go, because if you say, oh, I uploaded it 10 minutes ago, and they're like, sorry, your pass isn't blue, you don't get to go in the classroom. They can't like take your word for it and go, oh, you're vaccinated, okay, that's fine, go on in, right? You have to have submitted that. It's right there in the app. It says like upload vaccine card, and it just has you take a picture of it, and then within whatever, some period of time, you'll be all checked off that you're vaccinated. So you have to have that. Then you'll come to campus, and there's a little screen. It says like daily screening. You click it. It says, do you have COVID symptoms? No. I mean, assuming you don't, right? Be honest. No, I don't have symptoms. Have you been exposed to people with COVID? No, I have not. And then it'll give you your pass. Now, if you've already uploaded your vaccine card, your pass will be blue. That means you're vaccinated and you passed the checkup. They'll give you a wristband. Okay. If you don't have your vaccine card uploaded and it hasn't been verified, even if you show up, they're not going to let you through. So make sure you're taking care of all of that stuff now, right? And it's not the rules are the rules. It's not a matter of like, okay, we'll let this one slide. If I'm on campus without a wristband, I'll be told to go home, and I'm a professor, right? So obviously the same thing goes for students as well. So you got to have that's what they're saying here, wristband and a mask. Be ready. Right? Be ready for that first day, because there's not going to be any recordings of the classes at that point, because we're in person, right? So if you at that point, if you miss a class session, you just don't know what happened. You're just going to be out of luck. You're going to have to sort of figure it out on your own. I mean, I can tell you what we did, but I can't teach the whole course again. You're going to have to kind of figure it out. So please be proactive. Please get yourself prepared now to be all ready to go. Have a mask. You've uploaded your vaccine card. You're all ready to get through the screening site and come to class, because if I see a person in class without a wristband, I am obligated to make that person leave. Right? I actually think it's a good idea. I agree with the rules, but what I'm saying is there's not like a choice on if you're telling me like, oh no, I got vaccinated, I just didn't upload my card. Sorry. The rule is I have to make you leave the classroom. So I just want everyone to be ready so we don't have to deal with any of that kind of stuff on day one. Okay. Are there screening sites throughout the campus or a specific place we report to? Yeah, good question. There are numerous screening sites throughout the campus, and I have only used 2 of them. So there's one, if you come in from the east lot, which is the one where they have the market on the weekends, you're going to see kind of like there's that lane where you come in, like if you're coming from Foothill High School, there's that lane that kind of goes the length of the parking lot. They have a screening site there, so you'll see it. It's like a big tented area. I'm sure they're going to have it blocked off unless they move it, since people are going to be using the parking lot, but I suspect it'll be blocked off. And then you'll go through there and they'll screen you. Basically, you're going to show them your phone. It's going to have the little pass on the phone, and if it's blue, they go, here's your wristband, and you move on. If not, then there's going to be like issues, right? So the same parking lot where we're going to be, on Day Road. So the same parking lot where you're probably, if you drive, where you're probably going to park, it's right, like the one right by my office. There's a screening center in there. And then the new kind of orange building with the weird walls where they're all kind of uneven walls and stuff, but it's a really nice building towards the front of the school. A little bit past the science building, there's a screening session. There's a screening, screening station there as well, kind of in that like courtyard area where they're kind of making it a courtyard type thing. There's a screening site over there. I'm sure you'll be able to tell because they have like, a lot of them have like the tent, so that the people in there aren't in the sun and stuff. So I'm sure it'll be pretty clear on that day where the screening sites are and stuff. So make sure you go through one of those. Otherwise, you're going to come to class and I'm going to go, oh, you got to go get screened. Because like I say, even if I don't have a wristband, the dean's going to tell me I got to go home. So I got to have it. I've done it a bunch of times because I've had to go into work. So I kind of know the routine. But I know it's going to be weird for some people because it's your first day of class and you're trying to figure all this stuff out. So I would say, give yourself some extra time on that day, and then do yourself a favor of make sure you're prepared. You got a mask in your pocket. You got, it's like I'm telling my kid all the time, every time we leave the house, you got a mask in your pocket? No, you got to go inside, grab a mask, so have a mask available, or I have to ask you to leave. Be prepared to get the wristband, or I have to ask you to leave. Okay. So just be prepared for that. I'll probably talk about it again next week because, no matter how many times I say it, there's going to be some people that get caught off guard. So just try to educate, share the information as much as possible. But so there's that. And then the school has published the final exam schedule finally. So they did it a little early. It's been coming out mid-semester, so they're actually on the earlier side, although it used to come out before the semester started. So we can see exactly when our final exam will be. Now, then people immediately want to know what the final exam is going to be like. I haven't 100% decided. This is my first time teaching the class, so I kind of want to see how the material goes in the second half, and then I will decide the best way to test on that. But before you take the test, I will give you updates as to here's what I'm thinking about the test that I'm writing. So you'll have some kind of an idea about what you're walking into, and also realize I don't like to trick people on tests. I don't like to throw surprises at people. It's just not my style. I just want to know if you learned the material you were supposed to learn, and I don't think I need to be tricky in order to do that. So, I think I'm known for pretty straightforward tests. Like, people aren't surprised, and they're like, "What? We never talked about this," or "He never assigned any homework like this." Like, you'll have done this types of problems that you need to do for the final. So, no surprises. But I haven't exactly figured out how I want to do it. Okay, so the final exam schedule. So what you do, this works for all your classes, not just my class, all of the classes. So what you do is you go here and you find the starting time for your class. So we're Tuesday at 1? Is that right here? Did I find it that fast? I think it's Tuesday at 1 p.m. is this class, right? Yeah, Tuesday at 1. So that means that your final exam is on the 17th, Tuesday the 17th, from 12:30 to 2:30. So that's a little different. You're used to, this is the thing about finals. They try to match up the times as best they can, but there's usually a shifting, right? Like I took a music class on campus a few years ago, and the final started 45 minutes before the normal class time. So if you're not paying attention, you just missed 45 minutes of your final exam, right? Which, you might want that 45 minutes in order to make sure that you're doing a good job. So just realize that final will start at 12:30. It will go to 2:30. Let's see. We are an on-ground class, so you will be taking your test in class. It will be mandatory that you show up to class and take the test because it's an on-ground class, right? And so you'll have to show up, do that. So plan accordingly because it's really a problem when students no-show on the final. It's bad. It's really bad because basically I can't make exceptions for it. And the school has their policy even right here on the final exam schedule. It says request for early or late exams. Students may request a petition from the division office. Approved petitions must be filed in the office of the division dean prior to the exam date. You have to get the dean's signature. So you have to get my signature and the dean's signature, and we don't usually sign off for things that were in your control. So if you waited till the last minute and then something went wrong, that's kind of on you, right? The two cases where we've done this in the time I've worked here, I think it was both times it was women giving birth to, right around the time of the final. So most people go, that's reasonable. Let her take it at a different time. That seems reasonable to do. But, people show up and they're like, oh, my car didn't start or my alarm clock didn't go off. Can't really make exceptions for that because the rest of the class went out of their way to make sure they were there when they were supposed to be there. It's not really fair to them to make exceptions for people that just didn't prepare properly. So if you need to show up a little early that day, give yourself an extra little bit of time to get to school to make sure that if anything does go wrong, you have some time to deal with it. It's a good idea because also it says the request to change the time or date for the final exam has to be submitted before the final exam. So if you show up halfway through the final exam and go, oh, my car didn't start, well, your petition wasn't filed and there's nothing we can do about it. So if you have some type of real legitimate medical concern or legitimate emergency why you can't take it, contact me and we'll talk about it. But usually 90% of the time that people have an issue with the final, it either was poor planning and that, a lot of Disney cruises apparently, I booked my Disney cruise, but it starts the day before the final. Sorry, it's not really fair to people in the class to change it because you want to go on a cruise. Like, that's not really appropriate. And then also just people like not being prepared the day of, not getting themselves to campus. A final's a pretty important thing. It's like a job interview. What you don't want to ever do is be even a second late to a job interview because they'll note it and go, if you couldn't get here on time for the job interview, like, what do I think you're going to do on a normal day of work? You're not going to show up, right? So it's like a job interview. You be there early to make sure you're not late, and then it makes a better impression. The same thing with a final exam. It's that important. Like, it's just a huge problem if you miss it, and usually it means that you end up failing the class. So do whatever you need to do to make sure you can plan ahead and be there for that final exam. Luckily, it's midday, so showing up early hopefully won't be a problem for people, just to make sure you're there and ready to go, right? And then I have to cut it off at 2:30, and then I'll start calculating course grades and then submitting them, and we'll talk all about that towards the end of the semester. But so now you know when your final is, and this works for all your classes. So if you have other final exams, you can figure out where they are, or well, they should be usually in the same place as your classroom, but the when is what I meant to say. When your final exams are, you can look it up and figure that out. And then if you're trying to book a cruise, just make sure all your finals end before that cruise starts, and then you're good to go. But if you come tell me you got a cruise on Monday, well, I hope you have a good enough grade that you don't need the final exam, because we can't really make an exception for that. So, okay. So just again, because some people get surprised at the end of the semester and they're like, what, you can't reschedule this for my cruise? Like, no, that's not really a good reason. So, okay, so that's the spring. So we got the final exam schedule. We talked about that, talked about coming back to campus, which I know it seems like it's far away, but we only meet once a week. So it's like I'm only going to see you one more time online, and then we'll be meeting in a classroom in person. So, yeah. So just sort of be ready for that. And I will probably open the windows in the classroom so we get some good ventilation. So if you get cold, bring a sweater or whatever it is that you want to do. Okay, with that said, yep. And then also, let's see, that's for the transfer center, right? So that should be good. Okay, we got that. Where am I? Oh, right. Okay, so I was looking over the homework. Most of you are about to start factoring, so I kind of reorganized. Let's see, I lost my Canvas screen. Let's open that. Right here. So I kind of reorganized from when I first had this stuff up here where it's the factoring, rational expressions, rational equations is down at the bottom. I know some of you have done most of these or some of these assignments, but most of you haven't really done these three right here. And that's kind of what we're going to be focusing on. So I know that one Tuesday where I had that meeting from my office that was, it was kind of awkward because I was in Zoom and it was hard to show as much stuff. I covered factoring a little bit that day, but I want to spend some more time today covering factoring because factoring is a huge part of being able to do the algebra in algebra. It's one of the most important topics is being able to factor because you're going to learn factoring in the section called factoring. And then in the section called rational expressions, you're going to be using factoring. And in the section called rational equations, you're going to be using factoring. So you kind of have to do this section first, and then you can do these, right? I originally had these orders in the way that it is in the course outline, and then after looking at it a little bit, I was like, this doesn't make any sense to teach it in this order. So that's why I reordered stuff and extended some deadlines, because I realized the original way it was set up from the course outline, that's what we all work from. When you teach, we print out this document called the course outline that you use to figure out what I'm supposed to teach and what I'm not, but the ordering didn't make any sense. So I restructured this in a way that makes more sense for students, but it's kind of three big topics. So we're going to cover that today, and then I think, let's see, do I remember the dates? You have till the 14th to do that. We may have to talk about a little bit of this next time, so we'll kind of see how far we get today. I think what happened in the Monday class was I got through factoring, but we didn't, think we got into rational expressions and rational equations. I've talked about them real briefly earlier in the semester, but I'll probably spend a little bit more time talking about those. And then the plan would be the week after that. So next week I'll talk about the rational stuff. And then the week after that, we'll be back in the classroom and we'll start systems. That's the plan. And we may have to deviate from that plan a bit, but that's the idea. Okay. And please mark your calendars. I know it's disruptive when we change things about a class, but when we have to be back in the classroom, I'm sure there's people that will forget or don't know we're supposed to be back in the classroom, right? One of my other classes, when I was doing census this weekend, I saw one student who had never shown up to class, and I was like, oh, should I drop this person? And I went, and they had like hundreds on all the homework. Like they probably did more homework than anyone else in the class. And I'm like, that's weird. This person hasn't come to class, but they've like aced all the homework. So I contacted him, and the person didn't even know that the class had meetings. He's like, what? We have class meetings? So it's just hard I know it's hard for students doing an online class in mathematics, but it's hard for teachers because as much as we try to get the information out there, there's always students who miss it. And when it's important, like we're in a classroom now, we really got to try to make sure people know they're supposed to show up to a classroom. So that's kind of where things are going, and we'll update things next week. So right now in Delta Math, you've got it's in a weird order on here. I couldn't get it to reorder things on the Delta Math. So it shows that up here at the top, it's got the rational expressions and rational equations, but you should do the factoring stuff first. So these ones that are factoring, do those first. This GCF, that's factoring. This is really, you can see it's factors in here. This is factoring, solve by factoring. Do those first, and then go back up and do the stuff with rational expressions and rational equations, because you can't, there's a couple sections up in this grouping, and then basically all of these, you're not going to be able to do them without factoring. Well, you won't know how to factor until you've done the sections on factoring. So do them that's in the order in Canvas, not the order that's in Delta Math, okay? So do this first. Do the factoring ones, then rational expressions, then rational equations, and then you're good to go. And let me check a due date here. These are, oh, right. And then our systems of equation stuff is due at the end of February. So that's all set up right. Yeah, that's all good to go. Right. Okay. Okay, so what is factoring? Let's talk a little bit about what I'm even talking about, and then we can get into the actual mechanics of factoring, right? So, and I know some of this you may have heard a couple weeks ago, but we're going to spend the whole time today on factoring and really make sure people understand it. So back when you were in your pre-algebra, you probably did a prime factor tree. right? Your teacher may have called it something different, but basically you're taking a number and you're breaking it down into its prime factors. And you might start with a number like 36, and your teacher says, hey, do the prime factorization of 36. And the most common way that you see this done is with what we call a factor tree. So a factor tree is where you break the number down into its components, smaller and smaller, until those pieces can't be broken down any further. And you end up with the prime factorization of that number. So you might go, well, what do you mean? You've got 36 there, but 36 can be broken down into different ways, right? 36 can be 6 times 6, 18 times 2, 9 times 4, 12 times 3. There's lots of different ways to get 36. So what do you mean the factorization is unique? When I say that there's only one, you all end up with the same factorization. But that's because you didn't factor it down all the way. So, you can say, well, 36 is 18 times 2. And then 2 is a prime, so you stop with the 2, but you keep breaking down the 18. And you go, oh, well, that would be 9 times 2 times 2. Okay, but still 9's not a prime, so you break that one down. And you go, oh, okay, so that's 3. Let me write them in a different order. That's 2. 2 times 2 times 3 times 3. And that is the prime factorization. Whoops. You can always let me know if I'm off screen, because I can't always, too many things to look at. I can't always see if I'm off screen here. So just, you can let me know in chat or something. So the prime factorization of 36 is 2 times 2 times 3 times 3, right? And even if you picked a different starting point, even if you said, well, I want to break down 36 differently, say, well, I think 36 should be viewed as 9 times 4. See how I'm doing it differently than, if we're theoretically in a classroom, I'm doing it differently than the person next to me. Well, how do you break down 9 into primes? That's 3. 3 times 3 times 2 times 2. See how you still end up with the same thing? 2 times 2 times 3 times 3, 2 times 2 times 3 times 3. The prime factorization of any number, you will all get the same answer. Your work might look differently along the way, but you end up with that same prime factorization. This is what we do with polynomials. We take a polynomial and we break it down into its component pieces, and your work may look a little different along the way than the person next to you, but in the end, your answer should be the same. So that's what we're doing. We're breaking it down into its component pieces. That's why they call this a factor tree. If you do it, it looks like branches, like a Christmas tree. If you draw it a certain way. That's why they call it a factor tree. We're doing the same thing for polynomials. So let's remember back to how polynomials work. Let's say I want to multiply 2 polynomials. And you go, wait a minute, I thought you were talking about factoring. Why are you saying that we're going to multiply polynomials? Because factoring's the opposite of multiplication, just like up here, right? What were we doing? We were dividing this down to get the prime factorization. To get back to 36, we just multiply all these numbers together, right? So multiplication and factoring are like opposite directions of each other. Okay, one is undoing the other one. So when I get down here, let's remember how polynomials work. Maybe I have x minus 3 times x plus 4. Now, you were probably taught different tricks for multiplying polynomials along the way, right? You see a lot of this in high school where they come up with real cute ways to help you remember what you're doing. Unfortunately, what that usually does is it creates where a person memorizes how to do the problem but has no idea what they're doing. People will like memorize these things, but then they forget it once they haven't, been in that class for a couple of months. Whatever your teacher taught you for multiplying polynomials, it's fine. You can do it that way. It just comes down to how you're organizing your work, right? I'll have students come up to me and say, oh, my teacher taught me a completely different way of multiplying polynomials. It's actually the same. It's just how you're organizing your work is a little bit different. Yeah, see, so there's a question. Yeah, so I can't share the screen because it's on its own device for the iPad. But if you jump into the YouTube link that's in the Canvas class meetings page, if you click the YouTube link, then you can see everything, right? You'll see all the links and everything that I'm trying to show you. You'll see all that stuff. So it's some people like to listen to the audio from the Zoom, and then they silence the YouTube stream and watch that one. So it just depends how you like to do it. So if you want to see the visuals, open the YouTube stream. What was I saying? So yeah, someone will come to me and say, oh, my teacher taught me a totally different multiplication. It's just organizing it. Some teachers teach you to organize it in a box method. There's one called the Chinese method that I don't even know if it came from China or what, but like there's all these different little methods. It's just how you organize your work, because I'll show students, see how I got a 15x here and you have a 15x here, I have a 3x here and you have a 3x here. It's all the same stuff. It's just like horizontal versus vertical versus a box. It's all the same thing. But what all polynomial multiplication comes down to is take every term in the first polynomial and multiply by every term in the second polynomial. So one common way that we're going to see, and you see the most, is a binomial, two-term polynomial, times a binomial. So if there's two terms here and you have to multiply that by two terms here, that's 4 multiplications that occur. And that's where your FOIL comes in. First, outer, inner, last. It's not anything special. It's just there happens to be a word FOIL that people can remember. So we go with that. So that's you do the first terms for your first multiplication, then the outer, then the inner, then the last. So it's really just helping you remember the 4 multiplications that you have to do, right? So if we do that, I get x squared plus 4x minus 3x minus 12. So you see you got your 4 terms there. This is your first, outer, inner, last. So if you're kind of trying to remember how that works, that's what it looks like. Now look at these terms in the middle. Those are like terms. Remember, like terms have the exact same variable type, and we can add them up. So x squared and x are not the same type of variable. You might go, people go, yeah, but it's an x. Yeah, but an x squared is a 2-dimensional object and an x is a 1-dimensional object. So that would be like comparing the length of your wall to the area of carpet. Doesn't really make sense. You can't add that together. Oh, let's take the length of this wall and let's add it to the area of the carpet. What would that mean? Like, what meaningful thing would that introduce? So x squareds and x's are not compatible from an addition standpoint. Okay. So the x's are, though. We have 4 x's and we have 3 x's. Right? And I know sometimes people try to do tricky stuff when they combine these and you're just overthinking it. And sometimes it comes down to a sloppiness of language. Like I'll hear students say things where like, you're hurting yourself by saying that. Like you're remembering something. It's helping you remember, but you're almost holding yourself back. So for instance, let me finish this and then I'll expand on what I'm talking about. So this is x squared. Okay, if I have 4 x's and someone takes 3 x's from me, then what do I have? I have 1 x left. Right? I had 4 x's, you took 3 of my x's, and I have a 12 here, and then the minus 12 at the end. Now some students go, isn't it supposed to be x squared? You had 2 x's in that problem. Right, when you multiply x's, you would end up with an x squared. But when you add them, it doesn't change. Right? It's like the example I gave. If I have 4 x's and you take 3 x's, I'm left with 1 x, not an x squared. Right? And just think if your x was representing apples. If I have 4 apples and you take 3 apples from me, what am I left with? I'm left with 1 apple. The unit, the object that we're interested in doesn't change, right? You wouldn't say, oh, I added 5 apples to 4 apples, so now I have 9 apples squared. But people do that with the x's for some reason, where they go, oh, 5 x's plus 4 x's is 9 x's squared. No, it doesn't change the object, just like apples didn't become apples squared. They were still apples. X's are still x's. That's when we add, right? But people will kind of mix up their rules and they'll go like, oh, well, I thought an x and an x made an x squared. Well, you're not indicating the operation. Don't be lazy. Say which operation you're talking about. An x multiplied by an x is an x squared, but an x plus an x is just a 2x, right? So we don't just don't try to keep your stuff so short that you're leaving out the important pieces like operations and stuff. So what we just saw was an example of polynomial multiplication. I started with things written as a product. See how this is written as a product? That means multiplication. We have x minus 3 multiplying x plus 4. It's written as a product. But once we multiply it out, it's not written as a product anymore. It's written as pluses and minuses, right? It's sums. We've got 3 different terms being added or subtracted from each other. Go, okay. So what we want to see here then is the directions. If I start at the top line and move down, then I'm multiplying. If I start at the bottom line and move up, then I'm factoring. So they are opposite directions of each other, just like up here. Breaking 36 down into its primes is called prime factorization. Multiplying that back out is called multiplying, right? Same thing here. Now, you go, okay, well, we've got these 2 different forms. Which one's the right one? Well, there isn't necessarily a right one. Sometimes you want it written this way, which is what we call standard form, where there's sums and differences. But a lot of the time, like a lot of the time, we want it written as factors. That's actually a lot of times more helpful to us. So a lot of times we're going to start with something that's in the standard form, and we want to turn it into the factored form. And the thing about factoring, it takes some practice, right? You can watch me do it, but it's one of those skills that really takes a little bit of you being hands-on in order to make it like sink into your brain. It's one thing to watch me and go, yeah, I understand what he did, but can you do it yourself? And if you don't do some homework, then the likelihood is a week later you're going to look at it and go, oh, it doesn't make sense anymore. I don't know what's going on. It's just one of those skills. It's kind of like I assume they still do this when you're young and you're learning your multiplication tables and you have to take like a time test on them, and you have to do those multiplications really fast. 3 times 4 is 12. 3 times 3 is 9. 3 times 9 is 27. And you know all those like super fast. It's kind of like that where you have to do those problems a lot and then you get good at them. But until you've done a few of them, you're just not going to be very good at them. So make sure you practice them. And that's what we're going to be looking at. Now, factoring is more challenging than multiplying. Okay, multiplying is pretty straightforward. You can like as you saw, but also you can have someone write a program for multiplying polynomials together. It won't even take very long. It's probably people that could do it in 10, 15 minutes. Factoring, that's a lot harder to write a program to do, and that sort of gives us an indication it's harder as a human to do as well, right? Because you're looking at this 12 and you're like, well, does that break down as 6 and 2 or 4 and 3? I'm not really sure. And then you have to try a couple things, see which one works. Just takes a little bit more effort. Okay, so what do we do? What do we do when it comes to factoring? Oh, and we're going to see lots of different ways. It's not like there's one reason we learned factoring. There's a bunch. When you do your work with rational expressions and rational equations, you'll be having to factor those things. Another thing we do is solving polynomials. A lot of times you're going to use factoring to solve the polynomials. Those of you who if you end up in a pre-calc class, you're going to factor stuff all over the place. So it's a really important skill. All right, so let's take a look at the greatest common factor. So the greatest common factor is really the one you should always try to do your first step, if you can help it. A lot of times there isn't a greatest common factor, and so you don't have to worry about it. But when there is a greatest common factor, it's going to make your life significantly easier to factor that out first. And also there are occasionally problems that you can't do anything with them until you factor out the greatest common factor. So what does that mean? Right? Think about that greatest common factor. In mathematics, especially relating to algebra, we try to name things exactly what they are. So let's see, a greatest common factor. What would that mean? Well, factor means it's a factor. So it's, like we were breaking things down into factors a moment ago. The thing has to be a factor. That means it divides the original polynomial. Okay. Common. What does common mean? Common has a few uses in everyday life. Like, you know, if you're a gamer, then common might mean one thing, because a lot of times they classify items in games like common means it's not very good and you run across it all the time. But the usage of common that we're trying to use here means that you have it in common with someone else or something else, right? Two things have the same characteristic. They have that in common, right? So all of you, what do you have in common with each other? Well, you're all enrolled in this class. You all have enrollment in this class in common. That's what we're saying. So a common factor would be something that is a factor of both things. So we have two things we're wondering about. What's in common? What is the common factor? And the greatest is what is the biggest one? There might be numerous common factors. Let's just get to the biggest one and do everything in one step. Okay? So that would look like the following. Let's say we've got 4x cubed minus 8x squared minus 12x. Okay, so I've got this. And we can see that this is really written in that standard form. So it's written as sums and differences, and that's okay for this, but we're supposed to factor this, which means we need to get this thing written as a product, right? Well, the first thing I'm going to look for is figure out, do those terms have anything in common? And looking at them, it looks like they do. So one of the things that you want, it's really helpful in mathematics, but also it's a good life skill for just problem solving. I mean, that's one great thing about mathematics is you'll find people who do well in math classes are really good problem solvers because they kind of learn these, you know, how to break things down into more easily achievable steps. So you look at this and you go, okay, can I break this down into different pieces? So I'm not... Like too often students are trying to look at the whole problem and solve the whole thing at once. And then they're like, I don't know, I'm not good at math, I guess. No, you're just not good at problem solving. You're not good at like breaking things down and attacking pieces of the problem and then putting it all together. So you shouldn't be looking at this and trying to do the whole problem at once. You should say, well, there's some numbers there, those coefficients, and then there's also the variables. Maybe I can just worry about the coefficients first and then worry about the variables second. And the answer is, yeah, that's the way to do it. Now, when you're good at this and you're really comfortable with this, sure, you might be able to do the whole thing at once. But in the beginning, when you're first learning, break it down into separate pieces. So I'm just looking at the numbers. 4, -8, -12. Okay, can I think of a thing that divides 4, -8, and -12? Yeah, it's going to be 4, right? Okay, so 4, that takes care of the numbers. The biggest, the greatest common factor, the biggest number that all of these terms have in common is a factor of 4, right? Okay. All right, now what about the variable? Well, I've got an x cubed, an x squared, and an x. So what's the biggest power of x that occurs in all three terms? Well, that's just x. They all have an x in it, but they don't all have an x squared in it, right? So the biggest thing I can factor out is just an x. And at this point, you're just dividing the 4x out from the rest of the polynomial. It's almost like reverse distributive property. You know when you have the distributive property and you're distributing it into everything? Now it's like we're dividing it back out, right? So, and you'll see when we're done, it even looks like a distributive property problem, right? So if I divide 4x cubed by 4x, I'm left with x squared. -8x squared divided by 4x would be -2x. And then minus 12x. Let's see. So minus 12x divided by 4x is going to be -3. Which actually, the part in the parentheses, I just did this on accident. It wasn't even supposed to come out this way. It just happens to be factorable, but we're not going to worry about that right now. The key for right now is see how I just took this greatest common factor, I pulled it out, and then what's left inside doesn't have any more common factors. I've reduced it as much as I could. Okay? So, but it's now written as a product. It's this 4x piece times the piece that's in the parentheses. We've written it as a product. That's why we care about factoring, is to be able to do that. So the greatest common factor stuff's pretty straightforward. Most students do pretty good with it. You just say, what's the biggest thing I can pull out from all those terms? And then you divide it out from all those terms. a lot of times you'll be able to then continue factoring. Like, I'll just kind of show you since we're here. Usually if you just make up a problem, it's not going to be factorable, but in this case I made it up and it actually is factorable. But we would continue to factor and it would look like 4x, and I'll show you how to do this factoring in just a minute. It would look like x minus 3, and then what, x plus 1. And that would be the full finished version of the factoring as soon as it renders here would be that. So you don't know how to do this piece yet, or you might not remember, but I'll go over it. But just be aware, sometimes there's multiple steps of the factoring. Okay? All right, greatest common factor is a type of factoring that comes up. It comes up a little less often than the others, and I'm not even sure if it's going to come up in the Math for Meds portion. I kind of suspect it might not, but I'm not sure. But there's really good videos. I basically can't do any better than the videos that are posted between what I've posted and the stuff online. So if you're doing the factor by grouping section, just watch those videos that are posted, and then you'll be good, right? You should be good to go with those. You just follow those. It's the same procedure every single time, just different numbers and stuff in the problem. So you just keep working on that. Okay, so the most common factoring that you're going to be doing in general in an algebra class is trinomial factoring. So what is a trinomial? A trinomial is a polynomial that has 3 terms. So for instance, x squared minus 7x plus 12. Right? That's a trinomial. It's got 3 terms in it, and we want to factor it. So what are we going to do? Well, again, I see a lot of students. This is a chapter where I see a lot of students kind of staring at the ceiling, and they're like thinking it's the answer is going to come to them, that it's going to show up. Don't do it in your head. I think I've mentioned this before, but you're going to hear me say it throughout the semester because students really resist this, and then when they finally try it, it works great for them. Don't be doing stuff in your head. Write it down on a piece of paper. And if you go, well, I don't want to make my homework look all messy, then have a separate piece of paper that's your scratch paper. And it'll be a mess when you're done, but guess what? You can crumple it up and throw it in the trash. But it's really helpful to you, or recycle it, whatever. It's really helpful to you while you're doing the homework in order to be able to write that stuff down. Because I would say most of the mistakes that happen when people are doing math happen in their heads. They're trying to do 2, 3, 4 steps at once and remember the last step and think about what the next step's going to be. It's too much. Just write it down, right? It's that go slow to go fast. Take a little bit more time writing it, but you'll make less mistakes. Mistakes take a huge amount of time to fix. It just goes smoother. So you kind of break this down into pieces and you go, okay, what do I need if I'm going to factor this? Well, I know I need parentheses. Okay, great. Throw your parentheses in there, right? When you're writing them on a piece of paper, give yourself a little bit of space. But the typesetting software I'm using, it doesn't leave that empty space in there until I fill it up. So you would write parentheses, but you'd give yourself a little bit of room to write stuff inside the parentheses. Okay? And then you just kind of, now we're like going to be little detectives. And we're going to look at our polynomial, and we're going to look for clues. And when we get clues, I'm going to go, oh, that tells me about the factored form of the polynomial. So in other words, x squared. Well, how do you break down x squared as a product? There's like one way to do it, x times x, right? Okay, so I know that there's going to be an x here and an x here. Okay. Got it. Okay. Now, I know there's going to be signs in this thing, right? It's either going to be x plus something or x minus something. So how am I supposed to know if I'm putting pluses or minuses in this thing? Well, let's think back to our polynomial multiplication, right? Remember we had our first, outer, inner, and our last. The L part of your FOIL, the part that gives you the constant, comes from multiplying the 2 numbers that are right here. And you might go, well, that's not very helpful, Dr. Frederick, because that's what we're missing is the 2 numbers. Right, but we can detect clues about that last number. So whatever those numbers are, when I multiply them together, what do I get? Positive 12. Well, what do I know about a number? If I do a multiplication and I get a positive number, what does that tell me about the things I multiplied together? What it tells you is the signs must have been the same. So what I know is that the numbers I'm going to write down here are either both positive or they're both negative. I don't know which one yet, but it couldn't be a plus and a minus because if I multiply two numbers with opposite signs, I end up with a negative, and we didn't get a negative when we did the L part of our FOIL, right? We got a positive. So that tells me the signs are the same. So they're either both plus or they're both minus, but if they were both plus and I did the inner part of my problem, well, if both of these were plus and I added them together, how would I get a negative number? That doesn't make sense. Well, then it must be that they're both negative. So we just got that it's x minus, right? This is the kind of reasoning you have to work through. You're almost reverse engineering the polynomial. You're wondering, like, how did we get these different pieces? And you're picking up those clues. Okay, so how do I know the numbers that actually go in here? Well, I know when I do the L part of my FOIL, those numbers multiply to 12. Okay, so it could be 4 and 3. It could be 12 and 1. It could be 6 and 2. How do I know which one it is? Well, think back to the outer and the inner part, right? This part for the outer and the inner. And then we added those together, right? So it looks like down here, the numbers when I add them together should give me -7. With a 6 and a 2, can we get a 7? No. With a 12 and a 1, can I get a 7? No. With a 3 and a 4, can I get a 7? Oh, yeah, that works. Okay, so now we know that this should be x minus 3 times x minus 4. And then what you do is you check it really quick. So we kind of do a method of what they call guess and check, which is you use, like, people think guess and check, you're just randomly guessing. If you just randomly guess stuff, you're going to be there forever doing the problem. But see how I really narrowed it down by looking for clues in the problem so that you can usually, when you get good at this, you're usually going to get it on your first attempt. But if not, you go, oh, right, that was dumb of me. My sign's wrong. And then you're going to go back and fix it. And then the second try, it's going to work. Is usually how it's going to go, right? So it's called guess and check. You make your best educated guess, not a random guess, but your best educated guess based on clues from the problem. You try it, and then you multiply it out. And you go, well, let's see. That would be x squared minus 4x minus 3x plus 12. Oh, yeah, that works. That's the right factorization because we know that's going to simplify to this. And we go, good, I got it. And so you got the thing done. So it's really easy to check factoring problems. All you have to do is multiply them back out and see if you get what you started with, right? I encourage you to do that because on Delta Math, remember when you get one wrong, you have to earn those points back again. And the way you earn those points back is by doing extra problems. So I don't like doing extra problems. I like to do the least number of problems that are, going to help me learn the thing. So I would encourage you when you do this, check your work before you put it in Delta Math, or you're going to have extra work to do by doing extra problems. So just multiply it out like I did here, double check it, and then you're good to go. Okay? So that's how you do the trinomial factoring. Well, we'll look at another example in just a second. I feel like there was something I was going to say about this. I guess not. So let's do another one. Oh, let's make this a plus. Okay, so we want to factor x squared plus 9x plus 14. I go, all right, so what am I going to do? Well, right out of the gate, I need parentheses. And I know students think this is silly sometimes when they have a blank page, and I'm like, well, do you know anything about the problem? And they go, no, I haven't figured any of it out. Well, are you going to need parentheses? Well, yeah, I'm going to need parentheses. Trust me, every little bit that you put on the paper is stuff that your brain is no longer having to focus on. And that's the whole point, is you want your brain to focus on the part you're stuck on, not on the parts that you already know. So if you know it's got parentheses in it, write them down, and then your brain doesn't have to worry about that. Okay, x squared, that's going to break down as x and x. All right, now it's time to be concerned about our signs. So let's, oh, I know what I was going to say up here. I'll mention it in just a minute on this one. Okay, so this plus tells us the signs are the same. They're either both plus or both minus, because when I do my L part of the FOIL, I get a positive number. So they're both plus or both minus. But if they were both minus, how would I get this negative 9x when I do the outer plus the inner term? It wouldn't work. So it must be x plus and x plus. Okay, so it's x plus something times x plus something. So what do we want here? We want things that multiply to 14 and add to 9. Looks like 7 and 2. And then we have our factoring. And if we multiply that out, we'll see that we get what we started with. Yeah. Sorry, I don't usually eat lunch, but I had some food before class, and now I'm all drowsy. Okay, so we have this. Now, a question that will come up is, oh, I got a different answer. When I did it, I got x plus 2, x plus 7. Those answers are the exact same answer. They are both correct. Mathematically, they're correct. Teachers will accept it. There's nothing that says which one of those is supposed to be the right one. If you think about the commutative property of multiplication, it would be like walking up on two people having an argument, and they're arguing over whether 20 is 5 times 4 or 4 times 5. And you'd sit there and you'd be like, well, you're both right. Why are you arguing about this? That's the same thing here. It doesn't matter what order you multiply them, you're going to get the same polynomial in the end. If you're not sure, multiply the top one out, multiply the bottom one out, you'll have the same thing in the end. So it doesn't matter. Now, with that said, sometimes students take that the order doesn't matter really far, and they mix up the rest of the problem and say, well, you said it doesn't matter if I change the order. The order of the factors doesn't matter, but the factors have to be identical, right? So in other words, let's try this one. Okay, so we're going to factor x squared minus 2x minus 63. And I go, okay. So in order to do that, I've got some parentheses. It's going to be an x and an x. Now let's see. When I multiply my L part of my FOIL to get my constant, I got a negative number. So what does that tell me? Well, the only way I can multiply two things and get a negative number is if one's a positive and one's a negative. So apparently it's going to be an x plus and an x minus. Okay. That makes sense. So now I'm looking for things that multiply to 63, and they multiply to negative 63 and add to negative 2. You go, okay, I think that's going to be a 9 and a 7. Okay? And we get our factoring. And this is correct. If we multiply this out, we want to check it before we put it in there. You'd get x squared minus 9x plus 7x minus 63. And sure enough, if you simplify that, you're going to get x squared minus 2x minus 63, right? What we started with. So then some students will say, okay, so then this is the same thing, right? Right, a student will go, well, yeah, I got the same thing. You said the order didn't matter. The order doesn't matter, but notice these are not the same, right? This is an x plus 9, this is an x minus 9, this is an x plus 7, this is an x minus 7. So the factors are not identical. Not only did we change the order, but we changed the factors themselves. And you can see if I multiply this out, watch, what do we get? This is going to be x squared minus 7x plus 9x minus 63, which is different because up here, this one's going to simplify to a negative 2x. This one's going to simplify to a positive 2x. And that might seem like a small difference. It's not, right? A couple reasons. One, if you start plugging numbers in there for x, the numbers that you get for this top one won't look anything like the numbers you get for the bottom one. They're very different. Also, a negative's a big deal, right? If you go to the bank and you expect that you have $1,000 in your account and they actually say, oh, you have negative $1,000. You owe us $1,000. That's a big deal, right? That's a $2,000 swing. You thought you had $1,000 and they're saying you owe $1,000. That negative is a big, big difference. So don't take that lightly. I hear that from students like, oh, I was just off by a negative. No big deal. Off by a negative could be a very big deal in a lot of situations. So look out for that, okay? All right, so that's your trinomials. Well, that's the easier of the trinomials. So let's do one from here just to see what it looks like. Trinomials, factor this one. So let's do this. So I'm going to go, okay. I know I've got parentheses. I've got my x and my x. Okay, ways to break down 80 that add to 18. Oh, I bet it's 8 and 10, right? Plus 10. Plus 8. That looks right. I kind of multiply it out. And, I have an awful lot of practice with these, so I can check them in my head because, it's literally part of my job to do these all the time. So I'm pretty good with them, but I would recommend that you write them down, check them before you submit it. And, of course, I do make mistakes from time to time. Okay, some of you have learned to write this with a big X on it. That's totally fine. It's like I was telling you earlier, like there's some people like to organize their work differently. That's all it is. Like some students will try to say like, no, this is a totally different method. It's exactly what we just did, except you drew a big X on your paper, because what did we do? We talked about what multiplies to 880 and adds to 18. The only difference is I wrote it horizontally on a line, and some of you like to draw a big X on your paper. I've never really seen why drawing the X is helpful. I don't really get it because it's literally the same question. What multiplies to 80 and adds to 18? But if the X helps you, that's great. Use it. Like, don't be afraid to draw a big X on your paper if it means you're going to get the problem right, okay? Whatever you need. Okay, and then you just, you go through and do these. These ones are pretty straightforward. X. This one's going to be what? Minus, and 6 and 3. Nope. 9 and 2. Submit your answer. And then you get them. So those are, they are what they are. Okay, then we get into things where the lead coefficient is not a 1. Now it gets a little more complicated. The good news is a lot of times you luck out and they give you a prime number on these. The prime number is helpful. But these are more complicated than the ones we were just doing. So when the coefficient on your x squared term is not a 1, if it's not a 1, then the game changes a little bit, the way in which you get those factors to work. Yeah, some people call it the diamond method. Some people call it the big X method or the X method. Like, I've heard a number of different names for it. But yeah, you can try it whichever way you like. And there's nothing wrong with it. I just, like I'll ask a question and then students are like, oh, if you draw an X, it helps me answer the same exact question. I've never really understood why the X was helpful, but it's all good. Like, I'm not trying to, run down that method. If it works for you, go for it. Okay, 5x squared plus 37x plus 14. Let's see if I can remember that. 5x squared plus 37x plus 14. That's wrong. I already know it's wrong. But I will do what I encourage many of you to do, which is to just double check before you work it out. I would say in the classroom, probably half the time that a student gets an answer, they call me over and they're like, I don't know why I'm getting this wrong. It's because they wrote the wrong problem on the page. That's why they're getting it wrong. Oh, I was right. I did get it right. I thought maybe I messed up the middle term. Okay, we want to factor this thing. Now, like up here, we just said, well, what multiplies to 63 and adds to -2? We don't get to do that anymore because this 5, it's now a combination of factors, and that 5 messes it up. So we have to be a little bit more careful. Okay, so the good news is, since 5 is a prime, there's only one way to break down 5x squared, right? That's going to be 5x and x. That's it. Okay. Well, now let's look at our signs. Well, if I have a positive 14, that means the two numbers I multiply together to get the 14 are the same sign. Well, if they're the same sign and my middle term is positive, it must be plus plus. Okay, so we're going to go plus, plus. All right, but we can no longer look at what multiplies to 14 and adds to 37. That's going to be a problem because we now have this 5 that's part of my inner and my outer. So we have to think about one of these numbers is going to get multiplied by 5, and then when we add them together, we get 37. So, you know, you just kind of, this is one of those things where it's like, I'm pretty good at this because, you know, I studied math for a long time, and then once I stopped studying math, I taught it for now, 13 years. So I've done thousands and thousands of these problems, so I can kind of do them by looking at them. But when you're new, it's really hard to see the right combination. Like I'm seeing here, like I think I want the 7 to multiply the 5 to give me 35, and then I had 2 to get 37. But when you're first learning these, you're not going to see it that clearly. You're not going to see it in the way I can see it. Some of you will get there pretty quick, right? Some people pick up factoring really fast. But if it takes you a little bit of practice, that's okay. You just try it and see if it works. So I'm going to try a wrong one first and just show you, okay, we tried one, didn't work out, turn it around, try another one. All right, so let's say we want to do it this way. 5x plus 7 for x plus 2. I go, then that's my best guess. Okay, I'm going to see if that's right. And then when I do it, when I multiply it out, I get 5x squared plus 10x plus 7x plus 14. And we look at it and go, that's not right, because that middle, oops, sorry, I'm off the screen. Oh, always let me know if I'm off the screen. Okay, so when I add the 10x and the 7x, I get 17x. This isn't right. That doesn't match 37x, so I messed up. But you go, but I'm kind of close. The 5x squared came out right. The 14 came out right. I wonder what I could do. Why don't we just switch the 2 and the 7? Okay, let's do that. So now it's going to be 5x plus 2, x plus 7. And then when we multiply it out, 5x squared. So we're going to get plus 35x plus 2x plus 14. And this time we go, yep, that's the one. Because 35x plus 2x gives me my 37x. There we go. And that's kind of the way you want to approach it. I'll watch people in class, like in the same group, and they'll try it, and they'll get it wrong. And then like one person's kind of complaining, like, oh, I guessed it wrong. I got to try something different now. And then in the time that person was complaining, the person next to him just like finished the problem. They like redid it. They're like, oh, I'm going to swap these two and see if it works. Oh, yep, I'm done. And the other person was still kind of like grumpy that they had to try another one. Like, just try to have a good attitude about it. We tried. The first one didn't work out. We're trying a second one. Oh, that one worked out, right? It's how guess and check works. Occasionally, your first guess is not going to be right. No big deal. It doesn't mean you're not good at this or that you can't be good at it. It just means you got to practice a little bit more. And the more of these problems you do, what you're going to notice is you can mentally start to like your first guess is going to get better and better because you're kind of going to get like an intuition where you're like, I bet the 7's supposed to go here. And then you'll notice that you're right much more frequently, right? But it takes experience, it takes practice to get to that point, which basically is doing homework. It takes you doing homework to get there. Okay, so that's how the trinomial, so let's see, 5x plus 2x plus 7. So let's go. We have 5x plus 2, x plus 7. Submit the answer. And there we go. And you can see they guide you through it. When you get one wrong, I would say spend some time reading. Like there's a reason they put all this in here is because then you can see the right way to do it. In fact, it's kind of interesting that I kind of like how they have this programmed. I think this is new. I don't remember this being in there before. You can pull up your version and figure out why, if you got it wrong, why is my version wrong? Oh, because I get 17x in the middle. That's not right. I must have done something wrong there. You can see why yours are wrong, and then you can see why the correct one is correct, and it'll help you do better next time. Let's see, I'm trying to remember what level 2 is. This one's about the same. Okay, this is where they get a little bit trickier, and this isn't too bad because the numbers are still small. But notice how we now have a 4 in front of the x squared. It's not prime. So what that means is you're probably going to take, it's going to take you extra guesses maybe to get this one, because so far all the problems we've done, we immediately knew how to break down the x squared term. If it's just x squared, then you break it down as x and x. If it's a prime times x squared, then you break it down as that prime times x, right? So like 5x squared we knew was 5x and x. We didn't have to mess around with it. But with 4x squared, I don't know. Am I supposed to break down 4x squared as 4x times x? Or am I supposed to break it down as 2x times 2x? You don't know until you're trying it. You just get your hands dirty. The sooner you get in there and just try something, the sooner you'll be done doing it, right? So this one takes a little bit more playing around. So let's work through it. 4x squared minus 17x plus 4. Okay. So what was it? 4x squared minus 17x plus 4. Oops. Yeah, plus 4. So I'm kind of already suspecting how we're going to do this, but again, it's because I do these so often that I can see the combinations when they're coming together. With you, you're just going to try a couple. Like for me, when I look at this, I'm like, well, with the factors of 4 and other factors of 4, I could get a 16. And if I have a 16 and a 1, I might get a 17. But also, let's see, if we broke it down a different way, a 2 and a 4 would give you an 8, and then a 2. Yeah, it seems like that 16 might be the right one. So you just try factors. So I'm going to guess that 4x squared is going to break down as 4x times x. So 4x and x. But it also could be 2x times 2x. We won't really know. I'm just trying it. The sooner I try something, the sooner I'll know if I'm on the right track or not. Okay, so we've got a plus here and a minus here. So hopefully you're getting comfortable with what that means. So I'm going to give you like 2 seconds. Just in your own head, predict what my signs are going to be in the factored form. See if you know. This one tells us they should be the same, and this one tells us they should be minus. So it should be 4x minus, x minus. Okay. And then the 4, kind of my idea was to match the 4 and the 4 to get a 16. So I'm going to put a 4 here and a 1 here. And let's see if I got that right. So this is going to be 4x squared minus 16x minus x plus 4. Yeah, that one's going to work. So it looks like that's the right one. 4x minus 1, x minus 4. So you just put your parentheses in there. 4x minus 1. And what was it? X minus 4? Is that what it was? And then again, it tells you how to do the problem. So that's your trinomial factoring. That's what you're going to be doing most of the time. You will run across difference of squares and difference of cubes problems. I don't think we actually probably will end up using difference of cubes that much in the class. So try to use the formula that's given in the problem. But I don't know. I could be surprised, and then we can go over it more later. But I don't think difference and sum of cubes play a huge role. But most algebra books do like to throw in what's called difference of squares pretty regularly. And the good news is difference of squares are really easy. So I think this is one reason they like to do it, is most students are pretty good with it. So a difference of squares, like I say in mathematics, we like to name things what they are. It's literally a difference of squares. Like that's literally what it is. So when we say difference of squares, it would be like 25x squared minus 36y squared. Oops, I didn't put it in math mode. There we go. Should display in just a second. Here we go. Difference of squares. So what do we mean this is a difference of squares? Well, in mathematics, difference means subtraction. Okay, I see a subtraction. What are the things I'm subtracting? They're perfect squares. A perfect square is something that can be expressed as a thing times itself. So 9 is a perfect square because it's 3 times 3. 4 is a perfect square because it's 2 times 2. It's the same number multiplied by itself. Well, 25 is a perfect square because it's 5x times 5x. 36y squared is a perfect square because it's 6y times 6y. So when we have a difference of squares, there's a very convenient formula that follows. What you do is you take the square root of the first piece, and that gives us 5x. And you take the square root of the second piece, and that gives you 6y. And then what you're going to do is one of your factors is the sum of those two things, and one of your factors is the difference. In other words, our factored form would be 5x plus 6y, and the other one is 5x minus 6y. And there you go. That's how you do difference of squares. You take the square root of both pieces, you add them together, you subtract them, those things get multiplied. The reason difference of squares is interesting is it's a pattern that we use multiple times in algebra, where basically what happens, here I'll show you. When you multiply this out, it looks like it's going to be a mess, and then all of a sudden everything gets really nice. So when I multiply this, I get 25x squared. My outer is minus 30xy. My inner is plus 30xy. And then I have a minus 36y squared. But notice right here, my inner terms cancel. And it just becomes 25x squared minus 36y squared, the thing we started with. So that canceling in the middle is a pattern that we use in algebra in different ways. And it's one reason that makes difference of squares really, most students pick it up within a couple problems, right? They sit down, they try 2 or 3 by themselves, and they're like, okay, I get it. I get how this one works. You don't usually have to spend as much time with it as you do with, say, trinomials in order to get that done. Okay, give me just a second to catch my place. I've been doing a lot of talking. Let me make sure I don't have anything I'm skipping here. I think I'm covering it pretty good. Let's see. Let's go back and look. So we got difference of squares of binomials, greatest common factor, factor by grouping. Oh, right, solving. That's what I promised we'd look at some solving, and we need to do that. So solve quadratics by factoring. Let's look at that. Okay, so here we have an equation. Now, people get confused. What's the difference between an expression? Everything we've dealt with so far today was an expression. And now we're dealing with something that's an equation. Well, you want to know the difference because the rules that apply to expressions are different than the rules that apply to equations. For instance, you might remember that we can add the same thing to both sides of an equation. That's a tool that we're allowed to use. But what do you need to do in order to add something to both sides of an equation? You need an equation. I see some people try to add the same thing to both sides of an I think they're trying to force it into like a expression. But if there's no equal sign, then how do you add something to both sides of the equal sign if there's no equal sign? So we want to recognize this thing here is an equation. And usually what we do with equations is we solve them. Okay, it's very different. What we've been doing so far was factoring expressions. That's different than solving an equation. So it's always a good idea. There's kind of two things, and I see students miss out on both of these. One is read the directions. I'm always amazed when people just dive into something without reading the directions, and I look and I'm like, clearly you know how to do math, but you didn't do the right math because you didn't read the directions. So take the time to just read. Oh, solve for all values of x by factoring. Okay, so I'm going to have to factor, but then I have to solve. Okay. The other thing is, if you see an equal sign, probably you're solving. If you don't see an equal sign, probably you're just factoring. But again, read the directions to know for sure. Okay, so let's do this problem. X squared minus 2x minus 12. X squared minus 2x minus 12 equals negative 2x plus 4. Okay, so here's the steps that you take to solve an equation like this. Our goal is to solve. Remember, solving means we're going to get values for x that when we plug them into this original equation, it's true. Okay, how many are we supposed to get? The degree of your polynomial is the number of solutions you're supposed to get. So when you solve a first degree polynomial that's a linear equation, you get one answer. When you solve something like this where it's a degree 2 polynomial with the exponent 2, you get 2 answers. If you solved a third degree polynomial, so it had a cubic in it, a third degree polynomial with a 3 in the exponent, you'd get 3 answers. So I'm expecting when I do this problem right to get 2 answers. That's a good check to ask yourself when you start solving an equation. Sometimes you can do this, like with polynomials you can always do this. With other types of equations you can't always do this. But it's helpful to look at it and go, how many answers do I think I'm going to get? I think I'm going to get 2. So if we end up with 1 or 3 or 0, we might have made a mistake. Okay, so let's see. First thing we want to do is get 0 on one side of the equal sign. We do that by using the addition rule that allows us to add or subtract from both sides of the equation, the rule I was just talking about a few minutes ago. But how do I know if I want 0 on the left or 0 on the right? Well, we usually want this x squared to be positive. It just makes things a little bit easier. So I'm going to leave this x squared on that side, and I'm going to move these things to the other side, leaving the x squared positive. Right? You don't have to do it that way, but it's just a little cleaner. So let's see. If I do that, I've got x squared. So I'm going to add 2x to both sides. Oh, look at that. Our 2x's cancel out on both sides. So those are just gone. And now I'm going to subtract 4 from both sides, and I get minus 16. But it equals 0. Okay, is everyone clear how that came about? When I added 2x to both sides, the x terms just went away. And then when I subtracted 4, negative 12 minus 4 is negative 16. Now notice how I still wrote it as an equation. There's a tendency for people they lose the equation halfway through the problem. And, you know, students will go, oh, well, I just like to write it again at the end. Which doesn't really make sense because usually when students stop writing it as equation, what they do is they just factor it and they stop. They go, oh yeah, aren't they just supposed to factor this? If you keep writing an equation, besides being mathematically correct, way to do it, also you remember, oh yeah, I'm solving an equation. I'm not just factoring a polynomial. I have to solve this thing. Okay, hopefully you're seeing that this is a difference of squares. So now that we have 0 on one side, I'm going to factor the side that's factorable. So this is x minus 4, x plus 4, 4 from the problem we're looking at, right? The difference of squares problems. Okay. Now here's where this property comes in that's important. It's called the zero product principle, sometimes the zero factor property. It goes by a bunch of like various names, but really it's a property about the number 0, which is really important. We have certain numbers that have really special properties that, you know, if you're not that into math, you go, oh, what's the big deal? But the power of the zero factor principle or the zero factor property is huge. Without it, we couldn't solve this equation. So what it says is if we have two things being multiplied together, say a times b equaling 0, so if a times b equals 0, then a equals 0 or b equals 0. Now, what does that mean? I just said a bunch of stuff, but what does it mean? What it means is in the real numbers, if you multiply two things together and you end up with 0 as your answer, then 0 was one of the things you multiplied together, right? 0 times 4 is 0, but you can't multiply two numbers together that are non-zero and get 0. The only way you get 0 is by multiplying one of the numbers being 0. Okay, and people go, well, yeah, doesn't that work for every number? No. What about the number 6? I can multiply two numbers together that are not 6 and get 6. 2 times 3 is 6, but 2 is not 6 and 3 is not 6. That's different than 0, where I say if you multiply two numbers together and get 0, one of those numbers had to be 0. Okay? So what that means is if we let's see, why did it not update? What's going on? Oh, I somehow ended up on a different page. Was I not showing it the whole time? Wait. Oh, I just wrote this on the wrong. Sorry, I wrote this in the wrong section. There, it should end up there. Okay, so what this means is I'm multiplying two things together. Remember, the whole point of factoring is to write it as a product. So I'm multiplying two things together, and I'm getting 0, which means either this first factor is equal to 0 or the second factor is equal to 0. Okay, so then we set the factors equal to 0. So if x minus 4 equals 0, well, that's an easy to solve equation. Then that means that x equals 4. Okay. So there's one of our answers. And what about the other one? So the other one is x plus 4 equals 0. So if x plus 4 equals 0, then x equals negative 4. So those are our two answers. Are we right? I don't know. We should probably check it before we put it in Delta Math and then end up having to do a whole new problem, right? So luckily, when you solve equations, it's generally it's a lot easier to check your work than it is to figure out your work. So for instance, let's take the 4. So we'll plug it into the original equation. 4 squared minus 2 times 4 minus 12 equals negative 2 times 4 plus 4. So let's see, is this true? That would be what? 16 minus 8 minus 12, so negative 20. And this would be negative 8 plus 4. I messed something up. What did I do? (16 minus 8 would be, 16 minus 8 would be 8. Minus 12 is negative 4. This would be negative 8 plus 4. Yeah, it works out. Okay, so we know 4 works because it's a true statement here. The left side equals the right side. Now you would just check it with negative 4. And for the sake of time, I'm going to skip it, but you would check that, and then it would work, and then you would know, okay, I can put my answers into Delta Math, and I'm not going to lose a point. So how do you do that? We have two answers, and I know sometimes students get confused about the right way to enter them. So there's two ways you can do it. See, if I hit these plus or minus buttons, it allows me to put in more than one answer. It gives me a box for 2. The other thing you can do is just type a comma. So you can go 4, comma, negative 4, or you can use those plus minus buttons. Hit submit. Yep, and there we go. And you can see it works it out the same way I did. It's the same work basically. Okay, so that's how you do the factoring and how you use factoring to solve equations. So you want to move forward with that. I will talk about rational expressions and rational equations a little bit next week. If you feel like you want to move ahead and try to get it done on your own, go ahead. Right, nothing wrong with doing it that way. So yeah, that's where we're going. Kind of did the factoring today. We'll do these two next week. Sorry, I'm getting the hiccups here. And we'll finish that up next week. And then, like I say, 2 weeks from now, going to be setting up, or we should be in the classroom. And it looks like that's actually going to happen. I don't think they're going to change the date. I think we're actually going to be there in 2 weeks, ready to go and be in the class. Okay, so make sure you're getting all that taken care of. Make sure you're staying on top of the homework. It's the sort of the number one way to get behind in this class is you just sort of stop doing a little bit of homework, and then all of a sudden there's so much homework that it seems insurmountable, and then person just gets further and further behind. So you don't want to do that. Okay, So as always, I'm going to shut down the YouTube stream, but I will leave Zoom open. So if anybody wants to come ask me questions in the Zoom meeting, go ahead. Oh, and by the way, next week I should have all the information for you for the Math for Meds license. There was one little glitch that was taking place when I was trying to set up the program because I have to build it from scratch since I can't copy it from a previous Canvas course. There was one little glitch, but I met with the publisher and we got that taken care of. So I'm building the homework right now and should be all ready to go next week for you. And then you can either purchase the license then, or if you want, you can wait till we start it and purchase the license at that time, whatever works for you. But I should have that information for you then. Okay. All right. And I will talk to you later. Come see me in Zoom if you like. Thanks.